Next topic, angle between lines and planes. So the first one is angle between two lines. Suppose the line AB. A, the point, the coordinates are x1, y1, z1, and B is x2, y2, z2. Then how we get direction ratios of this line AB? How to find the direction ratios? You have to subtract. So direction ratios of AB are x2 minus x1, comma y2 minus y1, comma z2 minus z1. Okay. So here, if direction ratios of two lines are given, how to find the angle between those lines? So let A1, B1, C1 and A2, B2, C2 are direction ratios of two lines. A1, B1, C1 and A2, B2, C2 be direction ratios of two lines AB and CD. Then the angle between them is equal to AB and CD. Angle between AB and CD is cos theta. In terms of cos theta is equal to, you have to just multiply A1 A2 plus B1 B2 plus C1 C2 by root of A1 square plus B1 square plus C1 square into root of A2 square plus B2 square plus C2 square. And we have to take the modulus symbol. Acute angle only we are considering. Actually this portion is not, it is deleted portion, but we have to learn this, then only we can do in some questions in miscellaneous exercise. Okay, so I am just giving the result only. The acute angle theta between the lines AB and CD, if the direction ratios are given, direction ratios are A1, B1, C1 and A2, B2, C2, then the angle between them cos theta is equal to modulus. Modulus means positive value only we are taking. Acute angle means cos theta positive. A1 A2 plus B1 B2 plus C1 C2 by root of A1 square plus B1 square plus C1 square into root of A2 square plus B2 square plus C2 square. Okay, here direction ratios are given, then this formula you have to apply. Then the second one is the first one. Then one more thing, that is if these lines are perpendicular, then angle between them is 90 degree. So cos 90 becomes 0. Okay, so we can write the condition if lines are perpendicular. So cos 90 equal to 0 means the numerator part is 0. Then, so if two lines are perpendicular, then A1 A2 plus B1 B2 plus C1 C2 is equal to 0. These conditions are very, very important. Now, the second case, if lines are parallel. Parallel means theta is equal to 0. So cos 0 becomes 1, or we can say the direction ratios are proportional. A1 by A2 equal to B1 by B2 equal to C1 by C. Okay, so you have to learn these results. If two lines are given and the direction ratios are A1, B1, C1 and A2, B2, C2, then the angle between them is calculated as cos theta is equal to modulus A1, A2 plus B1, B2 plus C1, C2 by root of A1 square plus B1 square plus C1 square into root of A2 square plus B2 square plus C2 square. And if these lines are perpendicular, then A1, A2 plus B1, B2 plus C1, C2 is 0. and these lines are parallel, then A1 by A2. Ratios are proportional. B1 by B2 equal to C1 by C2. Then the second case, vector equations are given. Okay. If one line, what is vector equation of a line? A plus lambda B, that format. So vector R is equal to vector A1 plus lambda vector B1, and vector second line is equal to A2 plus some mu B2. Okay, lambda and mu are real numbers. So two lines, vector equations are given. Then the angle between these lines, angle between them, cos theta is equal to, okay, you have to multiply B1 and B2. Okay, when we calculate angle between them, this point is not at all important. You have to consider the parallel vector. Okay, so cos theta is equal to vector B1 dot vector B2 by modulus of that. Modulus is calculated like this, into mod B2. Okay, you have to take the modulus value of this. Now, if Cartesian form is given, what is the Cartesian form? X minus x1, that's a form. X minus x1 by a1 equal to y minus y1 by b1 equal to z minus z1 by c1. This is the first line. Second line, x minus x2 by a2, y minus y2 by b2, z minus z2 by c2. So two lines, Cartesian forms given, then angle between them, cos theta is equal to a1 a2. So the denominator part is parallel vector. This x1 y1 z1, we won't take that part, x2 y2 z2. We have to take the denominator part and multiply a1 a2 plus b1 b2 plus c1 c2 by root of a1 square plus b1 square plus c1 square, like the first form, okay, into root of a2 square plus b2 square plus c2 square. Then it's modulus. Similar to the first case, direction ratios given. Okay, so these three you have to learn. The first one is two lines, direction ratios are given, then how to calculate the angle between them. Then second one is lines, vector forms are given, two lines vector form. So you have to multiply cos theta is equal to b1 dot b2 by mod vector b1 dot mod vector b2. Then Cartesian forms given, then a1 a2 plus b1 b2 plus c1 c2 by root of a1 square plus b1 square plus c1 square into root of a2 square plus b2 square plus c2 square. Then condition, if two lines are perpendicular, a1 a2 plus b1 b2 plus c1 c2 equal to 0. If two lines are parallel, then a1 by a2 is equal to b1 by b2 equal to c1 by c2. That is, direction ratios are proportional. Now the next one is angle between two planes. So angle between, this is one plane, this is a second plane. What is the angle between them is angle between their normals. So this is the normal of the first one. Normal means the perpendicular vector is n1. So theta means between the normals, vector n1 or small vector n1 and small vector n2. Okay. So the plane, we have to consider equation of plane. First case is vector form. How to write the vector form of, we have four types equation, but generally the vector form like this. Okay, vector r dot vector n1 is equal to d1. The second plane, vector r dot vector n2 is equal to d2. Here also we don't consider this d1 and d2. That constant part we neglect. Then angle between the above planes, angle between plane 1 and 2, okay, is cos theta. Cos theta is equal to, you have to multiply n1, that is multiply means dot product you have to take, n1 vector n1 dot vector n2 by modulus vector n1 dot vector n2. Okay, take the modulus value. This is the angle between two planes. That means angle between the normals. Normal means two vectors. So we can find the angle between two vectors. Take the dot product, n1 dot n2 by mod n1 dot mod n2. Then Cartesian form. Second case is Cartesian form. The Cartesian form, the standard equation of a plane is x term, y term, z term and a constant. So a1x plus b1y plus c1z plus some constant d1 equal to 0. So first plane. The second plane, a2x plus b2y plus c2z plus d2 equal to 0. So two planes, Cartesian forms given, then angle between them. Again cos theta is equal to, so children look, 2x plus 3y plus 4z equal to 5 or minus 5, whatever constant. So this is a plane, equation of a plane in Cartesian form. Then these numbers 2, 3, 4, that are direction ratios of the normal. So from this you can write the normal. What is normal? In vector form you can write 2i cap plus 3j cap plus 4k cap. That is the normal to the plane. Or we can say 2, 3, 4 are direction ratios of the normal to the plane. Okay. So when we write in this form, this a1, b1, c1 are direction ratios of the normal. Here a2, b2, c2. So angle between them is a1, a2, n1 dot n2. This a1, b1, c1 represent the normal. Here a2, b2, c2. So just multiply that. b1, b2 plus c1, c2 by root of a1 square plus b1 square plus c1 square into root of a2 square plus b2 square plus c2 square. Okay. Then condition, if two planes are perpendicular, then cos theta becomes 90, cos 90 becomes 0. So this numerator is 0. That is a1, a2 plus b1, b2 plus c1, c2 is equal to 0. Okay. Then the second condition, two planes are parallel. Then these are proportional. a1, a2, a1 by a2 equal to b1 by b2 equal to c1 by c2. Okay. So for planes you have to learn these two results and this also. The angle between two planes means angle between their normals. So if vector equations are given, cos theta is equal to vector n1 dot vector n2 by mod vector n1 mod vector n2. Take the modulus value. If Cartesian forms are given, then cos theta is equal to a1 a2 plus b1 b2 plus c1 c2 by this d1 and d2 we don't take, by root of a1 square plus b1 square plus c1 square into root of a2 square plus b2 square plus c2 square. The condition, if two planes are perpendicular, a1 a2 plus b1 b2 plus c1 c2 equal to 0. Two planes are parallel means a1 by a2 equal to b1 by b2 equal to c1 by c2. Now what about angle between line and a plane? So one plane, this is the line. So this line and this plane. Here we have, for every plane there is a normal, the perpendicular vector. So let theta be the angle between the normal and the line. So normal we can write as n cap, vector n and for every line there is a parallel vector. So I am writing angle between line vector form vector A plus lambda vector B and the plane. Vector equation of the plane vector R dot vector n is equal to D is, here this theta is the angle between the normal and line. So for normal we have this vector n and for this line vector B. So cos theta is the angle between those two vectors, that is cos theta is equal to B dot vector n by mod vector B mod vector n. It's modulus n, that is cos theta. But the angle between line and plane is not theta, it is, this part is 90 degree, so this portion is 90 minus theta. So we have to find 90 minus theta, that value only we have to find. So cos theta is like this, cos theta is same as sin 90 minus theta, or you have to find the value of theta, then 90 minus theta you can calculate. Otherwise cos theta is same as sin 90 minus theta, so that's equal to mod vector B vector n by B dot n by mod B mod n. Or we can write, instead of 90 minus theta we can give another name, so B dot vector n by mod B mod n modulus value. So phi is equal to, therefore angle between line and plane, phi is equal to sin inverse mod vector B. Okay, this is the result. Now look here, two lines are perpendicular. Two lines are perpendicular means the condition A1 A2 plus B1 B2 plus C1 C2 is equal to 0. Two lines are parallel means A1 by A2 they are proportional. A1 by A2 equal to B1 by B2 equal to C1 by C2. Two planes are perpendicular, capital A1 B1 A1 A2 plus B1 B2 plus C1 C2 equal to 0. Two planes are parallel means they are proportional. A1 by A2 equal to B1 by B2 equal to C1 by C2. Then these two, what about these two? A line perpendicular to a plane. So fifth one, a plane and a line is perpendicular. For a plane we have this perpendicular vector n, isn't it? And the line is perpendicular to the plane. Line is perpendicular means line is also like this. Okay. So for every line we have this parallel vector B, then only we can write the equation. So this n and B are parallel. So a line perpendicular to a plane. A line perpendicular to a plane means plane, which implies vector B. What is vector B? The vector parallel to the line. Okay. Vector R is equal to A plus lambda B, the second part. That B is parallel to the normal vector. And vector n means it is the normal. Okay. So a line and a plane are perpendicular means the parallel vector of the line parallel to the normal vector of the plane. So using this result we can solve problems. Now the second, the last one, sixth one, a line is parallel to a plane. So plane, line is parallel means like this. This is the line. Okay. For this is the normal. So parallel vector is B. So what about n and B? They are perpendicular. A line parallel to a plane. That means vector B and normal vector are perpendicular. So the dot product equal to 0. Here they are parallel. So just opposite. Okay. Line perpendicular to plane means parallel vector and a normal vector are parallel. Line parallel to a plane means parallel vector and normal vector are perpendicular. Okay. Now using that we have to do problems. Find the vector equation of the line passing through a point and perpendicular to the plane. Find the vector equation of the line passing through a point. Single point is given. So required equation is a plus lambda b. That's the format. Okay. A is the point and b means parallel vector. That is not given. But given that the line is perpendicular to the plane. This is a normal vector. Normal to the plane. This is a line. Okay. The line is perpendicular to the plane. So for writing the equation we have this A but we don't have this B. For that B, can we take the normal itself since the normal is parallel to the line? Okay. For writing the equation we need B but B is not given in the question. Instead of B we can take this normal since the normal and the parallel vector or the line are parallel. So we can write the equation as vector A means I cap plus 2j cap plus 3k cap plus lambda into, instead of B vector we can take what? Vector n itself. And what is vector n? And this bracket gives the vector n. Okay. So I cap plus 2j cap minus 5k. Or when we convert this into the Cartesian form, that is x plus 2y minus 5z plus 9 is equal to 0. So 1, 2 minus 5, they are the direction ratios of the normal, or the normal vector we can write as 1i cap 2j cap minus 5k cap. Okay. Here the line is perpendicular to the plane. So the normal vector and line are parallel. So for parallel vector we can take the direction ratios of the normal or the normal vector itself. The next one, find the equation of the plane passing through and parallel to the plane. Equation of the plane passing through a point. And here vector equation, no, it is equation. So we can write the Cartesian form. So required equation, what is the format? First you have to write the format. Which form we use? We have 4 types of equation. But here the plane passing through a single point. So the format is A into x minus x1, isn't it? B into y minus y1 plus C into z minus z1 equal to 0. This is the equation of the plane passing through the point x1, y1 is z1 and perpendicular to the vector ai cap, bj cap, ck cap. Okay. So point is given x1, y1 is z1, that is ABC. But we don't know what is A, B, C, capital letters. So the condition is the plane is parallel. This is a plane, another plane. They are parallel. They are parallel means the normal also the parallel, or this is the plane. Okay. Can I convert this in the Cartesian form? X plus y plus z is equal to 2. So the normal vector is 1i cap plus 1j cap plus 1k cap. We have to write the equation of this plane. Passing through which point? ABC. Passing through ABC. And this perpendicular vector is not given. But is this vector perpendicular to that? Okay. Two planes are parallel means their normals also. The first one is normal, we can take for the second one also. So for ABC, we can take 1i cap, 1j cap, 1k cap. Or we take the number only. So 1 into x minus a, 1 into y minus b, plus 1 into z minus c equal to 0. Or open the bracket, x plus y plus z is equal to b plus c. Okay. Now one more question, that is that find the equation of the perpendicular drawn from the point 1 minus 2 3 to the plane 2x minus 3y plus 4z plus 9 is equal to 0, and also find the coordinates of the foot of the perpendicular. Okay. Find the equation of the perpendicular drawn from the point. Point is given as 1 minus 2 3 to the plane. So this plane is 2x minus 3y plus 4z plus 9 is equal to 0. So from P to the plane we draw one perpendicular. We have to find the equation of the perpendicular. So equation of PQ, we have to write what is the equation of PQ. Line PQ, it's a line PQ. Then find the coordinates of foot of the perpendicular. So Q is the foot of the perpendicular. So what is Q? This also we have to find. Okay. So for that, so I am writing let Q be the, let Q, we don't know the coordinates, we can give some coordinates x1, y1, z1 or alpha, beta, gamma, anything. So I am giving let alpha, beta, gamma be the foot of the perpendicular. Foot of the perpendicular drawn from the point as P to the plane, to the given plane. Is this much clear? Now, so PQ is a line passing through single point. Q is unknown, we don't know. So PQ passing through one point, that point is given. So we can write the equation of the line passing through the point, and we need the parallel vector. What is the parallel vector? For this plane we have normal. Is this normal is parallel to the line? Yes. So the normal vector means 2i cap, isn't it? 2i cap minus 3j cap plus 4k cap. The x, y, z coordinates gives the normal vector. So we can write equation of PQ. Equation of PQ is, write in Cartesian form, x minus x1. What is the point? The point is, first point is 1, x minus x1 by the parallel vectors first part, that is 2, is equal to y plus 2 by minus 3, z minus 3 by. Like this we can write the equation of a line passing through a single point and parallel to a given vector. Parallel to a vector means parallel vector we can take as normal. Now, so this is the equation of PQ. Okay. Now this Q lies on this line. What is Q? Alpha, beta, gamma. So we can give x, y, z as alpha, beta, gamma. Since Q is a point on PQ, we can write alpha minus 1 by 2 is equal to beta plus 2 by minus 3 is equal to gamma minus 3 by 4 equal to some lambda. So what is alpha? 2 lambda plus 1, beta is minus 3 lambda minus 2, gamma is 4 lambda plus 3. Okay, and these points again where it lies on the plane. So we can substitute in plane's equation. Alpha, beta, gamma lies on the plane also. Therefore, what is the plane equation? 2x minus 3y plus 4z. 2x, that is 2 alpha plus 4 gamma what is the last part? Plus 9. Plus 9 is equal to 0. Therefore, 2 into 2 lambda plus 1 plus 4 into 4 lambda plus 3 plus 9 is equal to 0. Now simplify. 4 lambda, 16, 20, 29 lambda, isn't it? Then 6 plus 2, 8, 20, 29. Okay. Therefore, lambda is equal to minus 1. So, what is alpha, beta, gamma? Alpha is equal to 2 into minus 1 plus 1. That is minus 1. Then beta is equal to minus 3 into minus 1 minus 2. That is 1. Then gamma is 4 into minus 1 plus 3. Is 3. So it is minus 1. So what is the foot of the perpendicular? Foot of the perpendicular. That is Q. That is equal to, what are the points? Minus 1, 1, minus 1. Okay. So that too we have to find. We have to find equation of PQ and Q. Equation of PQ already here. Then Q. Q's coordinates like this. Then in some questions, after this step we have to find the image also. So here we have P, then Q. The image of P, what is the image of P means you have to extend this, okay, to some point R. Let R be ABC. Then we have to find the coordinates of R. Okay. So Q here it is minus 1, 1, minus 1. And P is given, P is 1, minus 2, 3. Isn't it? 1, minus 2, 3. Okay. So what is the image of P? It is not in the question, but in some question this also will come. So what is image of P? So let R be the image of P with respect to this plane. Okay. So let R, ABC be the image of P. Then we can say that this PQ and QR are equal, or Q is the midpoint. Q is the midpoint of PR. Midpoint of PR. So apply midpoint result. So you will get R. So apply the midpoint formula. 1 plus A by 2. X1 plus X2 by 2. That's equal to the middle point. Then minus 2 plus B by 2 is equal to 1. 3 plus C by 2 is minus 1. So what is A? Minus 2 minus 1, that is minus 3. Then B is equal to 4, 2 plus 2, okay, minus 1. So what is the image? Image coordinates minus 3, 4, minus 1. Okay, it is very, very important question. Then sometimes you have to find the distance between P and R or P and Q. These are all these subdivisions of this question.